Hi guys. So we will solve this worksheet 9. I plan to finish it here in the video. And if you have any question, we can start with them in the online class. Okay, so I will solve the questions on the whiteboard. So let me share that. Right. Now worksheet 9, question 1. This is part G. Right, we have cosinus theta, cosinus to the 5, sinus theta, d theta. Right. Now for that, we will first make the substitution here. U is equal to sinus theta and du is equal to cosinus theta d theta. Then what do we get? Cosinus theta. So here we have, let me write, cosinus theta, and here we have cosinus to the 5 u, right? Sinus theta is equal to u, and d theta is equal to then du over cosinus theta. Right, so they will be cancelled. We get cosinus to the 5u du. Okay, now for that part, we will substitute now here. Let's call it v. All right, v is equal to sinus u, then dv is equal to cosinus u du, right? And then what do we get? So we have cosinus to the 4u, right? Here in the integral, we need to have some term with this cosinus u du. So we need to separate that cosinus from here. We get this. And this is equal to, this part is equal to dv, right? What about this? We know 1 is equal to sine squared u plus cosinus squared u for any u, and for any real number. So instead of cosinus squared, we can write 1 minus sinus squared u, right? And sinus is equal to v, so 1 minus v squared is equal to cosinus squared. But we have here cosinus to the 4. So what do we get? If we take square of that, we will have cosinus to the 4, right? So we will write it. So what do we have? Cosinus to the 4 is equal to 1 minus v squared, right? dv we have, right? Now, let's write it explicitly. We have 1 minus 2v squared plus v to the 4 dv. And you know, this is equal to v minus 2 over 3v to the 3 plus v to the 5 over 5 plus some constant. Now, instead of v, we need to have, all terms should be in terms of theta. So instead of v, we have sinus u, and u is equal to sinus theta. So v is equal to sinus of sinus theta, right? So instead of v, we just write that, and we're done. All right. Okay. Now the question, this question again, part H, we will solve. So we have x sine cube x dx, right? Now, let me write. We will apply integration by parts first. So we will call u is equal to x, and dv is equal to the rest, sine cube x dx. Then du is equal to dx, and v is equal to integral of this sine cube x dx. Now let's write this as in this form. This is cube, right? So sine squared x sine x dx. Then if we substitute here s equals to cosine x, then the s will be equal to minus sinus x dx, right? So this integral turns out sine squared is equal to 1 minus s squared, and sine x dx is equal to minus ds, right? So what do we get? Minus here, it will be equal to, and this one will be equal to s, and this will be equal to minus s cube over cube, so we will have plus s cube over cube. Now instead of s, if we write cosinus x, we have minus cosinus x plus cosinus cube x over 3. All right, so v is equal to this then. So by integration by parts, what do we get then? U times v is equal to this whole thing. We will write that cosinus x plus cosinus cube x over 3, right? And so what do we have? Minus integral of that cosinus cube x over 3 minus cosinus x dx. Dx is du, so we have dx. Now if we separate that into 2, we have this minus cosinus x plus cosinus cube x over 3 minus cosinus cube x, let's write that 3 outside, dx plus cosinus x dx, right? We know how to integrate this. Let's deal with that cosinus cube x. So call it a, for example. For a, if we substitute s equals to sinus x, and then ds is equal to cosinus x dx, right? So what do we get? We had before this cosinus cube x dx. So we need to have some term like this. So let's separate it. Cosinus squared x, cosinus x dx, right? Here we have cosinus cube again. Cosinus squared is equal to 1 minus s squared, and cosinus x dx is equal to ds. Here we have. Now what do we get then? Let's write directly s minus s cube over 3 plus some constants. Let's ignore that part. Here we will write that constant. So s is equal to sinus x. So we have sinus x minus sine cube x over 3, right? Hence, if we write this, so we were given this one, this integral x sine cube dx. So it was equal to this one minus cosinus x plus cosinus cube x over 3 minus 1 over 3 times a. A is equal to this now. Let's write it directly. Sinus x minus sinus cube x over 3 plus this one's integral is equal to sinus x, right? Sinus x plus some constant. So we're done. Now we will solve which part? The part on. All right. It's cotangent. The 5 theta sinus to the 4 theta d theta, right? Now let's write that cotangent explicitly. We know it's by definition cosinus over sinus, so we have cosinus to the 5 over sinus to the 5 sinus to the 4 theta d theta. Now if we simplify them in the denominator, we will have only sinus, right? So we have cosinus to the 5 theta over sinus theta d theta. We simplify them, right? Now for this, if we substitute u is equal to sinus theta, then du is equal to cosinus theta d theta, right? So we have cosinus to the 4 theta times cosinus theta d theta here, so it will be equal to du. Sinus theta is equal to u, so we have this. What about this cosinus to the 4? We know 1 minus u squared is equal to cosinus squared theta. So taking the square root of that will give us cosinus to the 4 squared over u du. Let's write it explicitly here. 1 minus 2 u squared plus u to the 4 over u du, right? Then we have 1 over u minus 2u plus u to the 3 du. Right? Now what do we get? It's equal to ln of u minus u squared plus u to the 4 over 4 plus some constant. U is equal to sinus theta. All terms should be in terms of theta. So by back substitution, absolute value of sinus theta minus sinus squared theta plus sine to the 4 theta over 4 plus some constant, and we're done. All right. Now part K we will solve. We're given tangent squared theta, secant to the 4 theta d theta, right? Now here we will substitute u equals to tangent theta, and then du is equal to secant squared theta d theta, right? What do we get then? It's equal to u is equal to tangent theta, so we have u squared. Second, so here in here we need to have some term like this, secant squared d theta. So this is equal to secant squared times secant squared d theta. So it's equal to secant squared times du, right? What about this secant squared? It's you know, you should know that this secant squared theta minus tangent squared theta is equal to 1, right? Then secant squared is equal to 1 plus tangent squared, and tangent squared is equal to u. So we have u squared 1 plus u squared du. We distribute it into the parentheses, gives this u to the 4 du, and then it's equal to u to the 3 over 3 plus u to the 5 over 5 plus some constant. U is equal to tangent theta, so we get this finally. Right? By back substitution, we get that. And now the part M, we will solve that. We're given this tangent to the 4t dt from 0 to pi over 4. All right, let's rewrite this first. This integrand, let's rewrite that as in this form, tangent squared t times tangent squared t dt, right? And as I said before, secant squared t minus tangent squared t is equal to 1. So tangent squared t is equal to secant squared minus 1, right? So instead of that, we write it. Let me write directly. So we have secant squared t minus 1 dt, right? From 0 to pi over 4. Now, what do we get? if we distribute it, we get tangent squared t secant squared t minus tangent squared t dt from 0 to pi over 4, right? And we can separate these two integrals. So let me write it here. So we have dt minus from 0 to pi over 4 tangent squared t dt. All right. Now, if we, so I continue from here. So if we substitute here, u is equal to tangent t, then du is equal to secant squared t dt, right? Then what do we get? So tangent squared is equal to u squared, and secant squared t dt is equal to du. So we have this. What about the boundary? When t is equal to 0, tangent 0 is equal to 0 because its definition is sinus over cosinus. So sinus 0 is equal to 0, so we get 0. And when t is equal to pi over 4, we already know it's equal to 1, right? So we have this now, minus. Now, instead of tangent squared, we write, using this identity, we write secant squared t minus 1 dt from 0 to pi over 4 again. Now, this is equal to u to the 3 over 3 from 0 to 1. And what about this? Let's separate this too. So we have secant squared t dt from 0 to pi over 4 plus dt from 0 to pi over 4. When we have a constant function 1, we don't write anything there, okay? The same with 1 dt. So here we get 1 over 3. For that part, we know the derivative of tangent is equal to secant squared, so we have tangent t from 0 to pi over 4. And here we get already pi over 4. You know, this is equal to tangent pi over 2 is equal to 1. Tangent 0 is equal to 0. So we get 1 there. Right? So it's 1 over 3 minus 1 plus pi over 4. And we're done. All right. Now the second question. All right. So we will start with the part A. First, let me show you the table for that. Here we have the table. So for such questions, we will use this table. I will not show this one again. If you want, you can go back here in the video and look at the substitution, okay? If you have such expression in the integral, you will use these substitutions, okay? So let me share the whiteboard. Oops. Okay. Now the question 2, part A. We are given this one, x dx over square root of this from 0 to 3. All right, if you use that table, you will see that you need to do the substitution. So we will call x equals to 6 sinus theta, right? Then dx is equal to 6 cosinus theta d theta, right? So let's plug these into that integral. What do we have? X is equal to 6 sinus theta. Dx is equal to 6 cosinus theta d theta, right? Over this one. Now, if you plug x squared there, you will get 36 sine squared. And in the parentheses of, here we find it. So you will have this, right? Now, in the parentheses of 36, you will have this. right? And you can write it outside of the square root as 6. This is equal to cosinus squared theta, and it's in the square root, right? So it will be outside. It will be equal to cosinus theta. So here we have 6 cosinus theta. So let's write it. Now, if we simplify them, this and this, what do we get? 6 sinus theta d theta, right? Now, what about the boundaries? When x is equal to 0, sinus 0 should be equal to 0 then, right? When x equals to 3, then we have 1 over 2 is equal to sinus theta, and then it's equal to pi over 6. So the integral of that is equal to minus cosinus theta from 0 to pi over 6. Then what do we have? Cosinus pi over 6 is equal to square root of 3 over 2. Cosinus 0 is equal to 1. So if you distribute that, you will get 3 square root of 3 minus, plus 6, right? Right. Now the part B, we're given this dt over t squared, square root of t squared minus 16, right? Now for that, we will plug, again using the table, we will plug t is equal to 4 secant theta, then dt is equal to 4 secant theta, tangent theta d theta, right? Now what do we get? Let's plug all of them into here. dt is equal to 4 secant theta tangent theta d theta over, now t squared is equal to 16 secant squared theta. What about the square root of that? T squared is equal to that, 16 secant squared theta minus 16, right? And it can, so it's in the parentheses of 16, we have secant squared minus 1, which is equal to tangent squared. So we will have 4 tangent theta, right? So we will write that tangent theta. Now simplify these. In the second in this. So what do we get? 1 over 16 d theta over secant theta. Secant theta is equal to 1 over cosinus, so we have cosinus theta d theta, and this one's integral is equal to sinus theta. Yes, right, plus some constant. We're not done because the integral is given by given in terms of t, so this should be in terms of t. For that, it's not hard. For that, we will use this identity. So if you write this theta, you see secant theta is equal to 1 over cosinus theta. So we have 4 over cosinus theta is equal to t, right? Just using this. Okay, secant theta is equal to 1 over cosinus theta. So we have 4 over cosinus theta is equal to t, which gives cosinus theta is equal to 4 over t. Then we replace, write them in this triangle. We have this. And then by Pythagoras theorem, we know this is equal to square root of t squared minus 16. Then sinus theta is equal to this over t. Let's write it directly here. Sinus theta using this triangle, sinus theta is equal to t squared minus 16. This is 16 over t. We have before 16 there, so we have this plus some constant, and we're done. Right? Now Which part? Part D we will solve. So it's du over u square root of 5 minus u squared. Now again, using the table, we will call here we have u is equal to square root of 5 sinus theta, right? Now let's, so du is equal to square root of 5 cosinus theta d theta, right? What do we get then? Du, let's write them, cosinus theta d theta over, now u is equal to this square root of 5 sinus theta. And what about this one? If you plug u squared there, you will get 5 sine squared. So we will have square root of 5 cosinus squared, sorry, cosinus theta. I will not mention that again and again, you know. How do we get that already? So if you simplify them, we will get d theta over sinus. Here we make some trick. It's possible that you cannot guess this, but you need to get used to them. So we have this actually, right? If you simplify them, you will get 1 over sinus theta, so nothing changed here. They are the same things. Now, what about this? For that, we will make some new substitution, right? So, as you see, we have sinus theta d theta. If we say, let me write here, for that, if not u, let's call it s. Now we will call, we will substitute s equals to cosinus theta, which gives this, right? D theta, right? And so we have sinus theta d theta here, right? So let's substitute that. So we have minus 1 over square root of 5 ds over sine squared is equal to 1 minus s squared. For that, we will use that table for partial fraction decomposition. I didn't show yet. I haven't showed yet that table. In the 4th question, I guess we will see that. But let's do that here together. So the aim here is to write that 1 over 1 minus s squared as a sum of 2 fractions, okay? So if we write this as in this form, this is equal to 1 minus s times 1 plus s, right? So we want to write it as in this form. So we need to find a and b, all right? So if you multiply this by 1 plus s and this 1 minus s, you will get a plus as plus b minus bs over this 1 minus s squared, right? Sorry, 1 minus s squared, right? Now you see it gives them a plus b, the constants here, is equal to 1, and a minus b, right? This and this gives a minus bs. There is no term here with s, so it should be equal to 0. Now solving this system, we get a is equal to 1 over 2 and b is equal to 1 over 2, right? So then this 1 over 1 minus s squared is equal to 1 over 2 over 1 minus s, 1 over 2 over 1 plus s. So we get minus 1 over square root of 5, 1 over 2, in the parentheses of 1 over 2, 1 over 1 minus s, plus 1 over 1 plus s. ds. Now we can write this 1/2 outside of this integral. So what do we get? We have 2 here. And separate this integral now into 2. What do we get? 1/1 minus s ds plus 1/1 plus s ds. And you know how to solve them. You will get minus 1/2 square root of 5 ln of 1 minus 1 minus ln of 1 minus s plus ln of 1 plus s, right? And plus some constant. So instead of s, we need to write what? We need to have terms in terms of u, right? So if we write instead of s cosinus theta, what do we get? It's equal to this. So let's write these. So instead of minus here, let's multiply them and get this 1 minus cosinus theta minus ln of 1 plus cosinus theta plus some constant. It's not important now. All right. Now, what about this cosinus theta? We know u is equal to square root of 5 times sinus theta. Again, we will use that triangle trick. So let's write it here. Now, again, we have this triangle. So it gives that sinus theta is equal to u over square root of 5, right? So we have u here and square root of 5 there. Now, what about this edge? By the Pythagoras theorem, we get it's equal to 5 minus u squared, right? So cosinus theta is then equal to square root of 5 minus u squared over square root of 5, right? So now the only thing we need to do is to plug this into here, right? And we're done. I will not write that again. You get the point. All right. Now, which part? Okay, this we will solve this part I. All right. Still, we're in the second question. Okay. We have the t over square root of t squared minus 6t plus 13. All right. Again, we will make some trick here. We need to make some trick here because in the table, you see all terms are like this, right? So we need to have something squared plus some other term squared, right? So we need to turn this polynomial into something like this. Now, what can we do about it? You see t squared minus 6t we have. Now, if we write this plus this 13 plus 9 plus 4, what do we have there? dt over, this is equal to this part only, is equal to t minus 3 squared plus 4 we have, right? So 4 is square root of 2, and this is square root of t minus 3, right? Now we have something like that, right? So if we plug here, u is equal to t minus 3, what do we get? So du is equal to dt then. Now instead of dt we have du over square root of. Now this is equal to u squared plus 4. Right, now we can use the table. So if you check that again, if we write u is equal to tangent theta, then du is equal to 2 second squared theta d theta, right? So if we continue from here, okay, it's equal to, now instead of du, what do we have? We have this whole thing, so let me write it first. Over, anyways, and inside of the square root, what do we have? 4 tangent squared theta plus 4. This denominator is equal to 2 second theta, right? And if we simplify them, what do we get? Second theta d theta. All right. Now we know second theta is equal to 1 over cosinus theta. Now again, same trick with the previous ones. Cosinus theta over cosinus squared theta d theta. Okay. Now I guess you can see what we will do. So for that part, we will substitute. Let's call it P or S. Right, there's no S here. Okay, let's call S sinus theta, then ds is equal to cosinus theta d theta, right? What do we get then? Cosinus theta d theta is equal to ds, and cosinus squared is equal to 1 minus s squared. Okay, and as we did before, we have now again 1 over 1 minus s squared. We know how to write it by partial fraction decomposition. So in the end, we will have, I don't know, 1 minus s, that was it. 1 minus s, minus 1 minus s, plus ln of 1 plus s, right? We just did that, okay? And so what do we get? S is equal to sinus theta. So we will write that. Let me write here directly. Minus ln of s is equal to sinus theta plus ln of 1 plus sinus theta plus some constant. Now you see the term should be, the result should be in terms of t. So instead of sinus theta, we need to write something in terms of u. So for that, I guess you can guess now, we will use that triangle trick. So here it says tangent theta is equal to u over 2, right? So we have u over 2, so we get this. Then what about this part? It's u squared plus 4 square root of that. Okay, then sinus theta is equal to 4 over this. So you need to write this, you need to plug this into here, into this equality. Instead of sinus theta, you will write this and we're done. Okay. All right. Okay, so the part J now. Actually, it's similar with the previous one, so let's skip that. Okay. Let's solve this one. Third, okay, it's quite easy. So I don't know if you can see that as I shared the whiteboard on me share again. So for these ones, we will try to write them as the sum of 2 or 3 fractions. Okay. So let me share whiteboard again. Okay. Now the question 3. Okay, part B, we're given this x squared over x squared plus x plus 2. Now for that, we will use polynomial division. We'll do that. So if we multiply this by 1, what do we get? X squared plus x plus 2. So we subtract from x squared this polynomial, we will get minus x minus 2. As the degree of this polynomial is less than that, right? The degree of this polynomial is 2 and the degree of this polynomial is 1, so we stop here. Then it is equal to 1 plus this remaining part, which is minus x minus 2, over this polynomial. The same with the numbers one. With the one with numbers. All right, so we're done. Now, what about the part C? We have 1 over x squared minus 9 squared. Okay, so this denominator can be written as in this form, right? 1 over, so the x squared minus x minus 9 is equal to x minus 3 times x plus 3. As we have square of them, we have square of these parentheses, right? Then it is equal to a over x minus 3 plus b over x minus 3 squared. B, you see the degree of that is 2, right? So we start with the first one, then till the degree of that, which is 2. If we add, for example, 3 there, then we would have this plus c over x minus 3 to the 3. Okay. Then we're done with this one. Now for that, we will do the same thing, c over x plus 3 plus d over x plus 3 squared. And we're done. Question doesn't ask to find these constants. Okay, so we won't do anything about this. All right. Let me share first the, wait a minute, that table for the fraction decomposition. I don't know if I have here. It will be easier to see that table as I have here. Wait a minute. Okay. All right. Now you see, I guess now. Okay, this is the table for fraction decomposition. Okay, so if you have in the denominator, if you have some term like this, ax plus b, so you will just write this one. If you have that power of this, ax plus b, this power k, as we did before for 2. So if we had k, we would write this one, okay, this sum. And if you have some term like this, ax squared plus bx plus c, then in the numerator, you need to have some polynomial with degree 1. Okay, you will write ax plus b, and you will find these constants. Okay, and if you have this power, kth power of this polynomial, then you would write this one. So the same with the previous, actually, the idea is the same. But instead, in the numerator, you have polynomial. Okay? And now we will solve this one. I will again solve that on the whiteboard. Okay, so the question 4, part B, I guess. Yes, B. So we have y over y plus 4 times 2y minus 1 dy. All right. So you see we have y plus 4 and 2y minus 1, all of them of degree 1. So we will by using that table, we know that this should be equal to y plus 4 times 2y minus 1. So we have a over y plus 4 plus b over 2y minus 1, right? So we need to multiply this by 2y minus 1 and this by this. What do we get? We have 2ay minus a plus by plus 4b over the same thing with this. Okay, I don't write. Then what does this give us? We see the multiple of y is 2a plus b, right? This one and this one. It gives 2a plus b should be equal to 1. The multiple of y is here 1. And the constant, there is no constant here, then b 4b minus a is equal to a, right? So using this system, we know how to solve it. I will not mention about that again. So a is equal to 4 over 9 and b is equal to 1 over 9. Okay, so this fraction can be decomposed into two. It can be written as the sum of these ones. Okay, so now what do we have? We have 4 over 9 y over, let's write. So we have 4 over 9 y plus 4 plus, it's 1 over 9, so we have 1 over 9 2y minus 1 dy, right? Okay, let me clear here first. So these are just multiples. We know how to solve this, how to integrate it. It's 4 over 9 ln of y plus 4, right? And plus 1 over 9 ln of 2y minus 1 over 2 by substitution. By it's easy. Let's call this 2y minus 1s. Then you will find differentiation and you will see that it will be equal to that. Okay, I will not mention it again. It's easy. Plus some constant we have. Okay, so by that table, using that table, you first decompose this fraction into two or into finite number. Okay, so then it is easier to find the integral. You will have something similar to you. Okay. All right. Now the part D of this question, or part D, we're given from 0 to 1, x cubed minus 4x minus 10 over x squared minus x minus 6 dx. Let me check again. Yes. All right, we will again use that polynomial division. So we have this over x squared minus x minus 6. So we will multiply it by x to get x cubed there. So you multiply it by x here, x cubed minus x squared minus 6x you get, right? Now we subtract that. What do we get? These are cancelled. What about this? Minus 4x. No, sorry. Here we have minus 6. If you multiply it by minus, you will get plus 6x. You have here minus 4x, so you will get 2x, right? And we have before x squared, so this we have minus 10. Now the degrees are the same. We need to continue to divide it. So multiply by 1. We get x squared minus x minus 6. We subtract that. So what do we get? 3x minus 4. Okay. The degree of this one is 2, and the degree of this remaining part is 1. So we're done. Okay. Then what do we get from 0 to 1? This can be written as in this form: x plus 1 plus 3x minus 4 over x squared minus x minus 6 dx. Okay, now for this part, it's easy. We know how to integrate it. What about this? We need to, again, decompose it. So for that, call this part A. Okay, so for A, what do we have? We will rewrite it. So you see this one is equal to x minus 3, x plus 2, right? So we can write it then a over x minus 3 plus b over x minus 2, okay? Then you multiply this by x minus 2 and you multiply this by, sorry, this is plus x minus 3, you will get ax plus 2a plus bx minus 3b over the same with this. So by solving the system, which is this, so a plus b, the multiple of x is equal to 3, and the rest, 2a minus 3b is equal to minus 4, right? So by solving them, you will get a is equal to 5 and b is equal to 2, right? Now, then it turns out that this, where do I write? Let's write it here. So you had before this x plus 1 dx plus this whole thing. So instead of, let's call the not a or star. Okay. Now, instead of this, we will write that. So it is equal to 5 over x minus 3, and b is equal to 2. So it's equal to 2 over x plus 2 dx from 0 to 1, right? Now, what do we get? Do we have there? So this one's integral is x squared over 2 plus x from 0 to 1 plus this is ln of 5 ln of x minus 3. Let's write like this, plus 2 ln of x plus 2 from 0 to 1, right? So if you plug x equals to 1, then x equals to 0, and if you subtract them, you will get this 3 over 2 plus ln of 2 minus ln of 3 in the parentheses of 3. Okay, if that part is easy, I won't go into detail there. All right, now the question F. The part F on me. So we are given this s squared, s minus 1 squared. Yes. Now for that, we will write it as in this form. So you see we have s squared. Now first we write s, then s squared. Now for this part, we write c over s minus 1 plus d over s minus 1 squared. Now you need to multiply this by s times s minus 1 squared, and this by s minus 1 squared, and this by s squared times s minus 1, and this by s squared. Okay, if you do that, you will get this one. 1 is equal to a times s minus 1 squared plus b times s minus 1 squared plus c times s squared times s minus 1 plus d times s squared. So you see, it's not that easy to find all multiples of s squared, s minus, all the constants. So it's not that easy. It's a little bit, there's a lot of computations, right? So instead of doing that, we will just put first s equals to 0, okay? Then it gives, if s is equal to 0, s is any real number, so it can take 0, right? Now, what do we get then? Here, these canceled out, then b times minus 1 squared is equal to b, so it gives b is equal to 1. If you put s equals to 1, then you will get d is equal to 1, okay? And if you put s equals to 2, you will get 1 equals to 2a plus b plus 4c plus 4d. Here, in here we put s equals to 2. We already know that b is equal to 1 and d is equal to 1. So if we plug them here, it will give us a plus 2a plus 4c is equal to minus 4. Divided by 2, it will give you this minus 2, right? Now this is the first equation for a and c. Now if you put s equals to minus 1, then you will have 1 equals to minus 4a plus 4b minus 2c plus d. You know b is equal to 1, d is equal to 1, so you plug them and you will get 2a plus c is equal to 2. And this is the second equation. Now if you solve 1 and 2, you will get a is equal to 2 and c is equal to minus 2. We had before b is equal to 1 and d is equal to 1. Okay, now the only thing we need to do is to plug here then. Okay, all right, let's do that. So what do we get now? This is equal to then a is equal to 2, so we have 2 over s squared, sorry, 2 over s ds plus 1 over s squared ds and plus c is equal to minus 2, so we have minus 2 over s minus 1 ds, and d is equal to 1, so we have 1 over s minus 1 squared ds, right? So it gives then 2 ln of s minus 1 over s minus 2 ln of s minus 1 plus, no, minus 1 over s minus 1 plus some constant. Right? And so we're done. All terms are in terms of s, so we're done. All right. The last question, 5. Okay, so we have here 5, the parts A, I guess. Yes. First, we will solve A. So we're given this dx over 2x plus 3 plus x. Okay. All right, now we will substitute here u equals to square root of x plus 3, and then you see du is equal to 1 over 2 square root of x plus 3 dx, right? And so what do we get here? So from that equality, what do we have? 2 times square root of x minus 3 du is equal to dx, and this is equal to u already, right? So we have 2u du is equal to dx. Now let's plug them over 2u plus x. What about x now? So we will use this equality for that. If you take squares, what do you get? You will have u squared equals to x plus 3. Then u squared minus 3 is equal to x. So instead of x, we will write that. So what do we have? 2u plus u squared minus 3, right? So for this, we will use, again, we will decompose this one. So let's write it here. Okay, we have 2u over u squared plus 2u minus 3, right? So we will write it as in this form. This is equal to u minus 3, u plus 3, u plus 3 times u minus 1, right? So we write u plus 3 plus b over u minus 1. Now, if you multiply this by u minus 1 and this by u plus 3, you will get, I will directly write the multiple of u and the constant, 3b minus a. We have the same with this denominator. Now then it gives a plus b is equal to 2, right? The multiple of u is here 2. And 3b minus a is equal to 0, right? And if you solve it, what you get, you will have a equals to 3 over 4 and b is equal to 1 over 2. So let's write it here. What do we get? A is equal to 3 over 4. So we have 3 over 4 u plus 3 plus 1 over 2 u minus 1 du, right? Okay, and you know the rest. So it's equal to 3 over 4 ln of u plus 3 plus 1 over 2 ln of u minus 1 plus c. U is equal to, was equal to square root of x plus 3. So instead of this u, you will write this, and we're done. Okay. Now the part d. So we have 1 over square root of x minus third root of x dx. Okay. We will first substitute in the question. There's a hint, so we will use that. So we will first substitute the 6th root of x. Okay. Then it gives u to the 6th is equal to x, right? And dx then, so let's write like this, dx is equal to 6u to the 5 du, right? And what about this square root of x and third root of x? So using this equality, u to the, so to get square root of x, we have third root of, the x cube of u cube is equal to square root of x, right? Power, third power of u. And u squared is equal to this, right? So using this one, right, taking the power 3 of both sides, you will get this, and taking squares, you will get that. So what do we get? Dx is equal to 6u to the 5 du. And here what do we have? This is equal to u cube, and this is equal to u squared, right? Okay, now we have polynomials. So by polynomial division, what do we get? Okay, multiply this by u squared to get u to the 5. So we have u to the 5 minus u to the 4. Subtract that, you will have 5. Sorry, we need to multiply it by 6 of that. Let me write again here. So we have 6u to the 5, u to the 3 minus u cubed. Okay, multiply this by that, 6u squared. So you will have 6u to the 5 minus 6u to the 4. Okay, and subtract that. What do we get then? Plus 6u to the 4, right? Now the degree of that is greater than this, so we need to continue. So we need to multiply by plus, we have 6 here, 6u, right, to get u to the 4 there. Okay, so we have 6u to the 4 minus 6u cubed. We subtract that and get 6u cubed here. Okay, still the degrees are the same. We continue with this 6. So we have 6u cubed minus 6u squared. We subtract that, and finally we have something with the degree less than this one. Okay, so we stop. Now we can rewrite this then as in this form. Plus 6 plus this one, 6u squared, over this u cubed minus u squared du. Okay. Now let's write it here. So what about this? We rewrite it. We can rewrite it as in this form. I'm sorry. Let's write here first. 6u squared. In the parentheses of u squared, what do we have? U minus 1, right? So we simplified them and get this. Now we can directly take the integrals. We have 6u cubed over 3, so we will have 2u cubed. And here we will have 6u squared over 2, so we will have 3u squared. And this will give 6u, right? And here we will have 6 n of u minus 1 plus some constant. Okay, u is equal to this, so the only thing to do is to plug this star into here, and we're done, right? I will not write that, so you already know how to find it. Okay, and so we're done with this worksheet 9. We solved all the questions marked with yellow. Okay, so we will start to the worksheet 10 in the next week. Okay, all right. If you have any question, you can send me email. Okay, I'll see you.